For problem 3 from the worksheet, we're going to need to talk about how to model exponential functions using e and also using the natural logarithm. So for this, I'm going to start off with another definition. If I have f of t equals c times e to the rt, this equation models exponential growth and decay. So R is going to be called the instantaneous growth or decay rate. You might also see this written as continuous growth or decay rate. So why we call it this is for the following reason. If we remember the function that we used to use before, and we'll still use it, but if we had f of t equals c times a to the t, and let's just assume this is an exponential growth function. This models exponential growth or decay, where the additional factor is being added on at every time period. So I guess if t is in years, and this models exponential growth, then whatever f of t is going to grow at one point every year. On the other hand, this continuous growth or decay rate, this means that I'm not growing. Let's just say t is going to be in years again over here. So now I'm not growing once every year by a certain factor. I am continuously growing. So in problem 3, I think we'll see a better example of this. Because what I've just said is a little bit nonsense without having an actual problem to look at. So problem 3 says, a population of 1.5 million is growing exponentially. What is the population 10 years later if the population has an annual growth rate of 14% versus a continuous growth rate of 14% per year? So annual growth rate what does that mean? So if we use P, or I guess maybe, let's say P of t to be the population after t years. The equation that we'll use for part 1 is P of t equals c times a to the t. And if the growth rate is 14%, this means that A is going to be 1.14. And let's say that our units for P of t are in millions. So that if we start off with a population of 1.5 million people, our C value is going to be 1.5. So our equation here will be P of t equals 1.5 times 1.14 to the t. And to figure out what the population 10 years later is, we'll just plug in t equals 10. So P of 10 is going to be 1.5 times 1.14 to the 10th. And once you plug this into your calculator, you'll get about 5.56 million people. So after 10 years, the population has gone from 1.5 million to 5.56 million. Okay, so for part 2, where it says a continuous growth rate of 14% per year, I'm going to explain what these things mean afterwards, after we get these equations written down. But since it says continuous, that's telling me that I need to use P of t equals C times E to the RT. And a 14% growth rate tells me that R is going to be 0.14. Just like R would be over here, right? So A is equal to 1 plus R. And again, our value for C is still 1.5. So we have that P of t is equal to 1.5 times E to the 0.14 t. And just like before, to find the population 10 years later, we're going to plug in 10 for t. And when we do that, and you put it into your calculator, you should get something like 6.08 million people. Okay, so the second part of the question asks, which assumption yields a larger population after 1 decade? The answer to this is the continuous growth rate. So once we assume continuous growth rate, we get a larger population. Okay, so let's really quickly write down what these mean. An annual growth rate. What this means is the following. It's sort of like the new people are being added to the population once at the end of the year. So it's sort of maybe like how if a town did a census every year and then reports the results of the census on like April 6th, for example, every year. So they're adding 14% of the population only once per year. In this case, I just assume that it's happening at the end of the year. So I'll say new people are added to the population one time at the end of the year. But if you think about it, that doesn't really make sense because realistically, not everyone has the same birthday. Not everyone arrives on the earth at the last day of the year. So that's where the continuous growth rate comes in handy. So if I'm using a continuous growth rate, this means that new people are continuously being added to the population. And this